is the solution. First, we want to get n, which is the length of the array, and we want to create an array called jumps, which is going to be filled with -1. We fill it with -1 because we want to keep track of which indices we've actually jumped to. We also need a queue, and we're going to insert 0 into it because that's the first index. And then we also want to initialize jumps of index 0 to be 0 because the first jump is free. We also need a neighbor map. The neighbor map is going to be used to keep track of all of the neighboring indices for the duplicate numbers. For example, if 1 is the first index and 1 is also found in the second index, the neighbor of index 0 is going to be 1 because they are the same value but on a different indices. So we need a neighbor map. Now we can go ahead into the while loop. While the queue is not empty, we want to first get the first element out of the queue. That's going to be current index. And then we also want to get the current value. And we're going to get that by doing array of current index. Finally, we want to get all the neighbors for that current value using that map that we created earlier. Now there's 3 if cases. First if case is to look through the neighbors. Second if case is to look for the left neighbor. And the third if case is to look for the right neighbor. For each of these, we want to see if there are jumps of the current index that we're looking at. It'll be either a neighbor index or it'll be the left or right. We want to see if it's -1. If it is, then that means we need to update the queue. We have to push that current index into the queue. And then we also want to update jumps of that index equal to be jumps of current index plus 1. At the very end, we want to return jumps of n-1 because we want to get the total number of jumps needed for the very last spot in the array. And that's the solution for this problem.